Okay, this is chapter 5.7, using congruent triangles. Essential question, how could you use congruent triangles to make an indirect measurement? What you will learn in this chapter section is how to use congruent triangles and prove constructions. I don't know if I'll get to constructions, but that's what the goal is. Okay, using congruent triangles. Congruent triangles have congruent corresponding parts. So if you can prove that two triangles are congruent, then you know that their corresponding parts must be congruent as well. Corresponding parts of congruent triangles are congruent. CPT, CPCTC. Oops. Corresponding parts of congruent triangles are congruent. CPCTC. Example 1, using congruent triangles. Explain how you can use the given information to prove that the hang glider parts are congruent. So we're given angle 1 is congruent to angle 2. So the first thing I'm going to do is redraw this diagram as just triangles in this diagram. And notice that the side QR extends beyond because we're going to use that external angle. So angle 1 is congruent to angle 2. So there's the congruent markers. And it says angle RTQ is congruent to RTS. So there's two congruent arcs showing that those two angles are also congruent. We're trying to prove this segment QT is congruent to segment ST. Okay, so then you mark deduced information. What can we deduct from that? So I just copied this over again and I'll mark it manually. So keep in mind, we're trying to prove the two triangles are congruent because then once we know the two triangles are congruent, every part in those two triangles that correspond to the other triangle are congruent as well. Okay, so we know that QT is congruent to ST if these two triangles are congruent. So what we're going to do is, let's see, RT is congruent to itself. We do know that by the reflexive property. Okay, so what else can we get from this diagram? Okay, so I know RT is congruent to itself. And I know angle Q is congruent to angle S. Well, angle 1 is congruent to angle 2. I can't call it Q or S because there's two angles there and two angles here. QR segment that extends beyond, this is a straight line. And this is a straight line. So if angle 1 is congruent to angle 2, let's say it was 160 degrees, then this is 160 degrees. And since this is a straight line, that forms a 180-degree straight angle by these linear pair. So this would be 20 degrees and that would be 20 degrees. Okay, and that's just an example. I don't know those measures, but I do know they're congruent. So I'm going to put 3 marks here because there's already 1 and 2. And I'm going to put 3 marks here. So now I know angle Q. Now I know angle RQT is congruent to angle RST. Okay, because they're linear pair to the congruent angles 1 and 2. So now I have 2 angles. And RT is congruent to itself by the reflexive property. So then I could say RT is congruent to RT. Okay, that's the reflexive property. So now I have an angle, I have a second angle, and I have a side. Okay, so now I can say triangle QRT is congruent to triangle SRT. And the reason is angle, side. So I like doing 2-part proofs more so than paragraph proofs. So we were given these 2 things. I didn't write them, but we were given them. And then you would say angle RQT is congruent to RST because of the definition. So you'd say definition of linear pair. Okay. RT is congruent to RT, reflexive property. Okay. And then we can say the triangles are congruent. And then we can finally deduce, and we can say that QT is congruent to segment ST, because QT is here, ST is here, and that is corresponding parts of congruent triangles are congruent. That's just my little shorthand for that. Okay, so those two triangles are congruent by angle, side. The two triangles are congruent, and then every part is congruent. So now you should be able to do problem numbers 3 and 4 in the exercises. Okay, example 2 is using congruent triangles for measurement. Use the following method to find the distance across a river from point N to point P. Place a stake at K on the near side so that NK is perpendicular to NP. Place a stake at K. So what I've done is I've taken this diagram and brought it outside here. So what they're telling us that we should do is put a stake at K on the near side. So what are we trying to do? Find the distance across a river from point N to point P. So I want to know what the length of the distance from N to P is across a river. Okay. We don't want to get our feet wet, so we can't just walk across there with a measuring tape and measure it. So we place a stake here at K so that NK and NP are perpendicular, forming this 90-degree angle. I'm just talking this through. Find M, the midpoint of NK. So then you'd find this midpoint, that by definition of midpoint, then MK would be congruent to NM. Okay, and it says an L, P, and M are collinear. So then we have 3 points on this line. So find a point out in the woods here, LM, and a straight shot over to P that's on the shore on the other side. So explain how this plan allows you to find the distance. Okay, so that's what we're trying to do here. So let me get rid of all this. So I've copied this down here. The stake is here. It's perpendicular to the line that we want to draw from N over to P. And then out in the woods here, L, M, and P are collinear. The M is the midpoint of NK. So NMK is congruent to NM. So the first thing I would say is we have statements and we have reasons. The book doesn't do it as a 2-part proof. They do it as a paragraph proof, but I'd prefer 2-part. So NK is perpendicular to NP. Okay? That's given. M is midpoint of NK. That's given. So now I can say NM, segment NM is congruent to segment KM. That's the definition of midpoint. Okay, so now I have a segment, a side, congruent to a side in the triangle. Okay, so since NK is perpendicular to NP, locate a point L so that NK is perpendicular to KL. So I could also put a comma here and say NK perpendicular to KL. That was also given. So now I can say angle N and angle K are right angles. Okay, and that's just definition of perpendicular. Okay, that came from this given. If you have perpendicular lines, they form right angles. So if N and K are right angles, I can now say angle N is congruent to angle K. And that just is because all right angles are congruent. Okay, so now I have a pair of angles. So I have an angle here congruent to this side congruent to this side. And the last thing I can do is, since these two lines are straight lines and they intersect, we have vertical angles. So angle NMP is congruent to angle KML. And it's because they're vertical angles. Okay, vertical angles are congruent. And so that is a pair of angles. And so I have an angle, I have a side, I have an angle, and the side is in between the angles. So now I can say triangle MNP. I don't care what I call the first triangle, but now I have to go in the right order. So I want to say M first. And N is congruent to K. So since N was second, K has to be second. And therefore L is last. So the triangle MNP is congruent to triangle, oops, I forgot my triangle symbol, MKL by side, angle, side. Okay, so now I can say LK, segment LK is congruent to segment PN. And that's corresponding parts of congruent triangles are congruent. So now I know this side equals this side. And it says, explain how this allows you to find the distance. Well, now that we have that all set up, I could measure from here to our stake that was set at K, and whatever length this is, let's say that was 50 feet, then that would mean make sure that'd be prove that that is also 50 feet across the river. Okay, so that's how you would find the distance across the river. Okay, now you should be able to do problem number 17. Okay, this is getting a little more complex. So I have a statement. And I have a reason. I'm going to do it with a two-part proof. Okay, so what we're trying to prove here is triangle BCE. This little triangle right here, okay, is congruent to this triangle here. That's what we're trying to prove. Okay, but there's a couple steps we need to do first. Okay, we need a part of that. So let's say we try to find how the length of CB is congruent to CD. If we can prove that, then we can prove the two triangles are congruent. But how do we prove these two are congruent first? Okay, so first start off by saying angle 1 is congruent to angle 2. Angle 3 is congruent. Oops. Angle 3 is congruent to angle 4. And the reason is given. So we already have an angle and an angle. So we have two angles already. All we need is a side to prove these two triangles congruent. So as you can see, triangle ADC and triangle ABC share side AC. So now I can say segment AC is congruent to segment AC, reflexive property. Okay, so now let me erase that. And let me put a congruent mark to show that AC is congruent to itself. So that is a side. So I have an angle, I have a side, I have an angle. Congruent to an angle, side, angle. So now I have enough information to say triangle ADC is congruent to triangle ABC. And it's an included side, so that's angle, side, angle. Okay? Well, so what did I just prove? Let me erase this. Let me show you. So now I know that this triangle here, okay, triangle A, B, C is congruent to triangle A, D, C. These are the two triangles congruent now because of angle, side, angle. So BC will be congruent to CD. So now I can say segment BC is congruent to segment DC. And the reason, corresponding parts of congruent triangles are congruent. Okay, so let me erase this mess. Okay, so now we do know this here. I'll leave those there. So now we have a side, CB. We have angle 1 congruent to angle 2. Remember, we're trying to prove these little triangles are congruent. And I have a side and I have an angle. So we have this right here. Now we're working with, we have an angle. And now we have a side. So we have an angle, we have a side. So now we just need another angle. Well, these two triangles are sharing segment CE. So now I can say segment CE is congruent to itself by reflexive property. Okay, and that gives us another side with an included angle. So now I can say the triangles are congruent. So I can now go right to what we're trying to prove. Triangle BCE is congruent to triangle DCE. And the reason? Side, angle, side. Okay, so that's how you do it. We first proved one triangle congruent to another to get the corresponding parts of that triangle that are in the little triangles, and then reflexive property to finish out our side angle side theorem. Okay, so that's how you prove that. That one's a little complex, 2 parts. So now you should be able to do problem numbers 9 and 10 after seeing that. All right, example 4 is proving a construction. We don't really do constructions in class. We don't have time in our class, but I will address it here a little bit. So solution, add B, C, and E, F to the diagram. Add segment B, C, and E, F to the diagram. So what we have here, we were given 2 rays that share same initial point A, forming an angle CAB. We have a copy of 2 rays sharing the same initial point D, forming this angle, which is congruent to the original angle. So what we're really doing is creating a copy. So the next step is they took a compass and they did an arc through CB, and a compass did an arc through FE with the same radius. So DF is equal to AC is equal to AB is equal to DE. These are all congruent. So that's congruent to that. That's congruent to that. And they're congruent to this one. So then they drew a segment from the arc intersection to the arc intersection. So now segment BC is congruent to EF. So we're given AB, segment AB is congruent to DE, and we're given AC is congruent to DF. And now we can say segment BC is congruent to EF. We're trying to prove angle A is congruent to angle D. Okay? So I won't mark that yet. We're trying to prove it. So the first thing we're going to do is our statement. We're saying AB, segment AB is congruent to DE, AC is congruent to DF, and BC is congruent to EF. And the reason is given. Okay, we're trying to prove the 2 triangles are congruent. Well, we made a triangle with this last side. So now we say triangle DEF is congruent to triangle ABC by side, side, side. Okay, we have three sides congruent. This side is congruent to this side. They're all given. We're given all three sides are congruent. All right, so now we have two triangles congruent by side, side, side. And this is really quick and easy. So now we have two triangles that are congruent. Well, don't forget that the corresponding parts have to be congruent. So now I can say angle D is congruent to angle A, and I will label my diagram. This is congruent to this. And the reason is that the corresponding parts of congruent triangles are congruent. CPCTC. And that's that. So now you should be able to do problem number 13. All right, that brings us to the end of chapter 5.7. These are the exercise problems I assigned my class. Hopefully we're doing those as you watch the video. And now 24 and 25 are review questions. So please do those. Thanks for watching and have a great day.